How's it going? It's Christian Hedges here again with another Automotive 240 video. In this video I'm going to show you a little bit and describe the operation of the 2020 GMC Acadia's MAP sensor. So the MAP on this vehicle is located right here. As you can see, we have it back probed on the signal wire. So here's the wiring diagram. The black and green is the ground, green and white is the signal. And let me scroll up here real quick. Right there, gray and red is the VREF, the voltage reference.
Once again, we are back probed on the signal wire of the MAP sensor on this here Acadia. We are sitting at idle right now, and we are sitting at about 1.3 to 1.4 volts right now. And you'll see right now, I'm going to have my partner increase it to 2000 RPM, and you'll see the voltage reading go up a little bit as the throttle plate opens, but then you'll see it settle back down to a lower value because the engine will be at a higher RPM and it'll be creating more vacuum. So you saw it jump right when the throttle plate opened, but as soon as the engine RPMs caught up, it went down to a lower value, and right now it's sitting at about 1 volt, 1.17 right there. And I'm gonna have my partner go up to 4000, you'll see the same thing again. So you saw when he made the large jump up to 4000, there is a large spike in voltage, and that's because the throttle plate opened a lot and a lot of atmospheric pressure was able to get into the manifold. But as the engine RPMs caught up, it created more vacuum in the manifold, and so the reading dropped. And then as you saw when he let off the throttle blade closed very quickly, and so vacuum got very high, meaning our voltage reading went down, and then it normaled out to where we are right now at idle. So right now we are taking a look at the signal wire from the MAP sensor. Right now we are at key on, engine off, meaning the throttle blade is cracked a little bit, so there's atmospheric pressure within the intake manifold, and we're sitting at about 3.78, 3.8 volts. And the reason for that is because pressure and voltage signal have a positive relationship, meaning as pressure increases, the voltage signal also increases. So we're going to go ahead and turn on and go to idle. As you can see, as soon as we go down to idle, the vacuum increases. We go to a lower pressure, and therefore we go to a lower voltage reading on our MAP sensor, sitting at about 1.2 volts right now. And if you look on our scan tool right here, we have a manifold absolute pressure in kilopascals of about 37. So we're going to go in and do a few wide open throttle snaps right now. So as the throttle blade is opening, there's more pressure going into the intake manifold from the atmosphere, so therefore the signal from the MAP sensor is also going up because more pressure means more voltage. And also on our scan tool during those snaps, we are going up to about 60 kilopascals. Right there, as you saw. Once again, with the throttle blade opening, more atmospheric pressure in the intake manifold, and a greater voltage signal coming from the MAP sensor. We're now going to be taking a look at the crank and camshaft position sensors on this 2018 Hyundai Tucson. Underneath the vehicle now, we're looking at the front side of the engine, and our crankshaft position sensor is physically located right there, and then it's got a bit of a lead, and its connector is located right there, and it is a 2-wire connector with a power and ground. As you can see, we have those currently back probed, and we'll be hooking our leads up to there to get some picoscope readings. This vehicle has a dual overhead cam motor, meaning there's 2 cams and 2 cam position sensors. First one is located right there, the 3-wire connector, and the second one is located back here, the same 3-wire connector, and they both receive power from the same yellow line with a black tracer, and you can see it clearly on this one right there. Taking a look at the service information here, as you can see, we have our 2 camshaft position sensors and our single crankshaft position sensor. The crankshaft position sensor is a 2-wire with a signal and a ground. It's a gray wire and a pink wire. So that will have an analog AC signal. And then our two camshaft position sensors, they're both 3-wire with a signal, a ground, and a power supply, which is fed by the same wire as I mentioned earlier. And these would have a digital Hall effect signal instead of the AC form.
So after back probing both our camshaft and our crankshaft position sensor, these are our readings on the picoscope. Right down here, this is our crankshaft position sensor, and up here is our camshaft, the green line. Our crankshaft position sensor, it has one missing tooth that you can see is right here, and each time you see that, that is one revolution of the crankshaft position sensor. Our camshaft position sensor, it's just got one elongated tooth that takes up 50% of the wheel, so that when it reads that the tooth is there, it is on right here, and then when it's not there anymore, it's down here at 0. Right down here, this is our comparison that we have to all data showing what it should be, and as you can see, it matches up with what we got pretty well, so everything looks good.
So this is what our two camshaft position sensors look like. Again, they are both the single tooth reluctor wheel, meaning they're on for half the time and off for half the time in the rotation. And this is what the service manual looks like with these two compared to each other. And then this is what our actual results are from the picoscope. And you can see that they are similar, so we would deem that these sensors are good. We're going to go ahead and do a little quick demonstration. So as RPM increases, the frequency of these two sensors increase. So the digital signal with an increase in RPM, an increase in frequency on the signal.
Real quick, I just wanted to show you guys what happens to the reading for the crankshaft position sensor when the vehicle is at a higher RPM. Theoretically, what should happen is the voltage should get higher, meaning the amplitude of this graph should raise, and then the frequency will also get closer together, so it'll look more just like a blue line. There you go.
So that was our demonstration of MAP sensors as well as crankshaft and camshaft position sensors.
That's all we have to say about that. Thanks for watching.